And with that, I'll hand it over to John in our offices in New York.
Hello everyone, thank you for joining us for today's TPMS training presentation. We're here live at Autel's North American headquarters in Farmingdale, New York. As you could probably tell, it's pretty quiet around here. Autel has placed a tremendous emphasis on the health and safety of our staff. Virtually all of our staff are working remotely. Only second to the well-being of our employees is our ongoing commitment to customers. Although our staff is working off-site, we remain fully operational, offering technical support, warranty services, order processing, and shipping to our customers. We understand automotive technicians are essential personnel. We want to thank you for being available to service the vehicles of our most important citizens, including medical personnel as well as first responders. Also keeping our trucks on the road so they can deliver supplies. We're very proud that Autel tools have been a part of the great work that you do. In today's training presentation, we're going to cover a variety of topics. We'll do a general overview of TPMS tools and sensors offered by Autel, review some key concepts and ideas, as well as perform a TPMS service demonstration live from our on-site repair shop. Before we get started, let's take a look inside our facility. This is our main office area where technical support sits. We have experts in this room in every area of vehicle service. Whether your question has to do with diagnostics, TPMS, ADAS, or even key programming, there's someone here who's an expert in that area of Autel's tool offerings. This is a new product that's entering its final stages of development. This is the MX-Sensor Ultra. When it's released, this tool will be the most powerful tool that Autel has ever created for diagnostics. So we're really excited about that. There's several offices here that help with order processing and fulfillment. This is our warranty and customer service department. Our techs respond to customer inquiries and meet any of the needs that our customers may have. In this area, we have technicians that assist with new tool registration and updating. This side houses a portion of our TPMS support staff. So any questions you have or issues that you have related to a vehicle that you're servicing or any bump in the road, our TPMS technical staff do an excellent job, and I'm sure they'd be able to provide a solution to any of your issues. One of Autel's major initiatives is training. This is our training facility where we regularly schedule training events and invite technicians and shop owners to our offices to take part in training in any of the areas of diagnostic or service products that we offer. So it's very, very important to us to maintain that personal relationship and actually get to meet the people who are using our products. This is where we house our warehousing and shipping area, as well as our on-site repair shop. So within our facility, we have a living, breathing repair shop where we test vehicle services, we test tools, we test new software updates for validation before they're released. And we actually spend a lot of time back here, even with our own vehicles, working on new products. Now that we've taken a look at our facility, let's talk TPMS. Once again, thanks for joining us. My name is John Amato. I'm a TPMS technical trainer with Autel. Today we're going to talk about TPMS, and we're going to start with some system fundamentals. There's two basic categories of TPMS systems. So we have direct and indirect systems. Starting with indirect systems, there actually aren't any sensors in the wheels. It uses rate of wheel rotation and information from the ABS wheel speed sensors in order to determine differential wheel speeds, and that indicates when you have a low pressure condition at the tires. Direct systems use tire pressure monitors installed in each tire at the valve location, and it also uses an antenna system to read radio frequency signals from those sensors. And in addition to that, there's a driver information center that will warn the motorist when there's a low tire pressure condition. So how does a TPMS sensor work? Or how does it actually transmit data to the vehicle? So that's what it actually does. So there's different ways to sort of wake up a TPMS sensor and get it to send information to the car. So what are the different ways that we can activate a sensor? A loss of tire pressure will cause a sensor to activate and send a signal to the car. A pressure deviation of approximately 25% of the vehicle's placard value, that's the factory recommended pressure, that'll cause a sensor to activate. Also on some older vehicles, you could use an activation magnet in order to get the sensor to wake up when you're servicing it in the bay. These will probably be familiar to you because they're on the side of a lot of people's toolboxes. Another way is we can use a TPMS tool like the TS508 to send a 125 kilohertz radio frequency signal to the sensor by means of the tool, and that will cause the sensor to wake up. So sending the 125 kilohertz to it with a TPMS tool is a way that in a service environment we can force that sensor to transmit and send information to the tool where we can collect it. Another way the TPMS sensors are activated is through centrifugal force. So as your vehicle speed reaches over 20 miles an hour, the sensor automatically transmits its signal with increasing frequency due to the accelerometer that's located in the sensor. At sustained highway speed, that would be a time when your sensor, for safety reasons, would want to transmit as frequently as possible to the vehicle. So if there is a tire pressure loss event, that the driver is warned right away. So what kind of information does the sensor send out after it's activated? So of course, the pressure inside the tire, the temperature, battery life is indicated in the Autel tools if there's an issue with a weak signal strength due to a low battery. Also the sensor ID. The sensor ID information is very important. So it's displayed in two ways. It could either be numbers or a combination of numbers and letters. So when it's all numbers, it's considered a decimal TPMS ID. When it's a combination of numbers and letters, it's considered a hexadecimal ID. So those are the different ways that a sensor could be activated to send information either to the vehicle to be registered on the dash or activated through the use of a TPMS tool or other means such as a Relearn magnet. Not all sensors are compatible with the Relearn magnet. A very special category of generally older sensors called magnetic activation sensors benefit from this, and you could find it in some older Ford vehicles. So it's pretty seldom that you'll end up using the Relearn magnet. So what are the different components involved in the system? What does the vehicle need to execute an effective TPMS system? So we have our receiver or the antenna that receives the signal from the vehicle's TPMS sensors when they transmit, once one of those conditions are met and the sensor does transmit. There also has to be a display. So there's a display on the dashboard, and there's two different levels of TPMS equipment that are available on vehicles today. So we have what's called a high-line system and a low-line TPMS system. And if you look at some of the menus within our TPMS tools, you will sometimes see options for vehicles equipped with high and low-line systems. So a high-line system is going to indicate that you get more specific information about the system from the driver information center. So if you look at the dash, it'll give you the pressures at each one of the wheel locations. With a low-line system, you'll only have a TPMS light that illuminates if there is a pressure deviation, right? So when you have that low-line system, you're going to need to do a little investigating just to see which tire is actually affected by the pressure difference, right? So in addition to the receiver or the antenna that receives the signal, you have the display on the dash and you have the TPMS sensors themselves. In terms of the TPMS light, all vehicles are equipped with a TPMS indicator light, and it's important to understand when you visually inspect the light that if you have a solid light, that means that you have a pressure problem. If the light is blinking, that means that there's some type of equipment failure within the system. And of course, the TPMS light will always be part of a standard bulb check. When the ignition is put in the on position, you will see that light illuminate as a part of the general bulb check. So take a look at this illustration. What we're trying to do, and really at the core of our understanding of TPMS systems, is this information. We can see in the image that we have TPMS sensor IDs, and in this case they're hexadecimal IDs. We have a unique ID at each one of the wheel locations. And you could see represented in the center of the vehicle, you have the TPMS ECU, or whatever controller or control module in that car controls TPMS or wireless system information. So our goal when servicing TPMS, and this is going to be true for any vehicle we work on in any different circumstance, what we're trying to achieve is that the sensor IDs and the wheel locations match the information in the car's TPMS module. Right? So continuity of that information is what we're trying to achieve. Each vehicle has unique sensor IDs at each location, and the reason for that is so when two vehicles are going down the road next to each other, one car is not picking up the signal from another vehicle's TPMS sensor transmission. So it's very simple, but all we want to do is make sure that the IDs at the wheels and the locations match the ID and the location that the vehicle thinks they're in. For instance, if you perform a tire rotation on a vehicle that has a highline system, meaning that you have exact pressures and wheel locations indicated at the dash, in many cases, as those tires are rotated, the display on the dash will show inaccurate information. So it's really, really important that we perform the necessary TPMS service procedures to make sure we have accurate information and that our systems are performing correctly. So a word on terminology. Okay, there's two basic terms in TPMS that are very, very important. One is a relearn procedure, and one is programming. And this is something that we hear conflated all the time. So a relearn procedure refers to any time we add a sensor ID to a vehicle or we change the location of a sensor ID, we need to teach the vehicle the location of that tire and the new sensor ID. Programming only refers to taking a blank sensor or a universal programmable style sensor, such as the Autel One sensor, and giving it an identity. In other words, programming so it's ready to be added to a vehicle in a specific application. Okay, but we're going to get into that more a little bit later when we talk about different sensor types. Okay, and what are the circumstances where we'd need a relearn? In the case of a faulty sensor, we're adding a new ID to the vehicle, so we'd need to teach the vehicle that ID. If we're performing a tire rotation, all of those wheel locations and those IDs are going to change relative to what's in the control module. Right? So we need to teach the car that we moved those tires around when we did the rotation. Also, if we replace the TPMS computer itself, when that new part comes from the dealer and we install it, the information that's not going to be in that controller is going to be the TPMS IDs and the locations of the wheels. Also, if we're installing winter tires, it may be necessary to do that if the IDs don't match. Okay, so there's three different types of relearn procedures. So they fit into three specific categories. The first one is a stationary relearn. So an example of a stationary relearn could be found on many Ford or GM vehicles where you have a multi-step procedure that sometimes involves cycling the ignition key, pushing buttons on the dash to put the car into a relearn mode. On some GM vehicles, you may remember you need to hold the lock and unlock button on the key fob when the key is inserted in the ignition. That's going to get the car into a learn mode. And in that factory learn or train mode, as it's sometimes called, you'll then have to activate each one of the sensors, starting with the left front and going in around the vehicle to the right front and so on to the other locations. And each time you activate one of those sensors, the horn's going to honk, indicating that the vehicle learned the position of that wheel and the sensor ID itself. Okay, so kind of complicated multi-step procedure. There's a lot of variation in different stationary relearn procedures, but the real benefit, and one of the major benefits to all of the Autel TPMS tools is that all of the information is always located on the tool, so it's your best piece of reference material that you have available. So you can look up the different procedures for any vehicle you're working on. You could look up applications, diagnostic procedures, so anything that you'd need to find, instructions are on the vehicle. So very beneficial for stationary relearn since there's so much variation in the way that they're executed. The next one is called an auto learn. Auto learn is the vehicle automatically will learn the location and the ID of those TPMS sensors. So it will localize the sensors. This is something you find in a lot of Chrysler vehicles, and this is a more complicated system electronically because there are antennas at each specific wheel, and as the vehicle accelerates for a period of time, those individual antennas at each wheel location are able to localize the position of the wheel. Okay, so pretty simple. If you add a new sensor ID or do a tire rotation on a vehicle that requires an automatic relearn or an auto learn, it's very simple to accomplish that by just going for a drive. Okay, the third category, the third different type of relearn is called an OBD relearn, sometimes referred to as OBD write to vehicle. So a scan tool is required for this type of relearn, as well as the stationary relearn because the tires need to be activated. Those sensors need to be activated. So an auto learn could be accomplished without a tool. However, diagnostics on that vehicle cannot be accomplished without a tool. So it's always best to have a very competent TPMS tool in your arsenal. So how does OBD write to vehicle work? And that's our third relearn type. OBD write to vehicle involves activating each of the sensors with a TPMS tool, like the 508, and you would start by activating the left front, right front, and the subsequent tires, and the tool then retains that information, and it knows that the ID at each location, and it knows the location of that wheel. So the tool will then ask you to plug into the vehicle's diagnostic port with the included OBD2 cable, and then what you can do is instruct the tool to actually upload that ID and location information to the vehicle's control module through the DLC or diagnostic port. So a lot of Asian vehicles utilize the OBD write to vehicle method. So those are our three different categories of relearn procedures. Really important to know. So there's several different types of aftermarket sensors available on the market. Okay, so in years past we'd call our parts store, they'd send over a part that supposedly was correct for the application we had, and sometimes we weren't sure how to properly implement that sensor because we didn't know what type it was, and the counterperson at the parts store couldn't tell us that information either. So there's three different types of aftermarket TPMS sensors. The first one is a direct fit. Early on, parts manufacturers were creating individual part numbers and sensors that were compatible with each application, and the effect of that was that some companies had 40 or 50 or even more different SKU numbers or part numbers that were available. So you really needed to be lucky to call and they'd have the correct one in stock, and let alone 4 of them. So direct fit sensors are the first category. Direct fit means one part number for a specific vehicle application. So there's no adaptability there, right? And also in such great quantities, it's really impossible to stock those sensors, so you're always stuck waiting on a parts delivery. So the second category, and this is when things got consolidated a little bit more, this is multi-application sensors, sometimes referred to as multi-fit. So parts manufacturers were able to create a sensor and scale down the overall inventory, but they were able to load a larger amount of vehicle applications onto that specific sensor. So rather than having 45 or 50 or more with a direct fit system, they consolidated that, and now it's only about a handful of sensors, probably 10 sensors, that'll cover not a very large amount, but a good segment of the vehicle market. Okay, so you'd have to have 10 sensors in order to cover each application once, and then 4 times that many to hope to have what you needed in stock for that particular car. That's not taking into consideration whether it had a rubber or metal valve. Third category is the sensor that Autel manufactures. The third category is called a universal programmable sensor. So we sometimes refer to this as a blank disk, right? So there's really no information on it aside from the electronics when we take it out of the box. So what we do with a universal programmable is, instead of relying on information that is already included on the sensor, like your direct fit or multi-fit sensors, what we do is we take the tool, we use the software in the tool to program a universal programmable sensor, and basically create a sensor that behaves exactly like the factory part for a specific vehicle. Great advantages to this. So as new model years come out, we don't need to produce a new sensor, we need to produce a new software program to go onto that sensor to increase compatibility as future model years are released. So with the older systems, you don't need to do that. Another advantage is that we can stock these sensors very easily. Because they cover such a wide range of vehicle applications, in our case, almost 99% of vehicles on the road can be serviced with an Autel One sensor. So we can stock these in our facility, no more wait times. We could pull one off the shelf whenever we require one and install it and get the customer on their way. Gone are the years when we'd have a car up on a jack for 25 minutes or more when we're waiting on a parts delivery, right? So we couldn't utilize that on another vehicle. So a lot of advantages to this sensor, great adaptability. All the strength in a universal programmable sensor is through the software on the tool. So remember, universal programmable, blank disk. Out of the box, it doesn't know what type of vehicle it's for. You'll need to activate it by programming it with our tool. So those are the three categories of aftermarket sensors. So programming methods. So although we have our blank sensor here, we have a vehicle we want to install it in, and we need to choose the correct method of programming this sensor. So there's 4 different ways that we can ask our tool to create a sensor for a specific vehicle application. The first method is called copy by activation. So copy by activation involves taking the original sensor that you need to replace. So in some cases you'd have a sensor where the valve is damaged or the body of the sensor is damaged, and you'd want to recreate that sensor ID on a new sensor. So what you can do is activate the old sensor. The tool will take the ID information and the vehicle application from that sensor, and it will put that information on a universal programmable, and you can install that. The vehicle can't tell the difference between a programmed blank sensor or universal programmable and the original sensor. Copy by OBD is the second method for programming universal programmable sensors. And this is virtually exclusive to Autel, and it's one of our innovations. It's called copy by OBD. When we talked earlier about the IDs at each wheel location and the idea that those IDs are stored within the control module in the vehicle that handles wireless systems, what we can actually do is even if a sensor is missing, broken, it won't activate, we can't get any information off of it, we can use our tool, our TS508 or TS608 tool, to plug into that car's diagnostic port and ask it, hey, what ID used to be at this location? Or what ID are you expecting to hear, expecting to see transmissions from the right rear? And it'll know that information. I sometimes use the example that if you're on a road trip and you get stuck, go to the local mechanic and they don't have a TPMS sensor or know how to service those systems, they may put a rubber valve in that tire for you just to get you home so the tire will hold air. So when you do get home to your mechanic, all the mechanic has to do using the copy by OBD programming method is plug into that vehicle. The vehicle's controller will output the information for the IDs and the wheel locations. All you have to do is select the wheel location you want to recreate the sensor for, and it will program an Autel One sensor with the information that the missing sensor had on it. You install it and the vehicle cannot tell the difference because it's the same ID transmission. Cuts down on additional steps. Copy by OBD is really a huge advantage that we offer to technicians, and it's something that saves quite a bit of time and gives you flexibility in your repair process. The third way that we can program sensors is programming by manual input. So what does that mean? If you look at a factory sensor, you can see that the sensor ID, whether it be decimal or hexadecimal, is going to be stamped on the side of that sensor. So what we can do using the arrow keys on our tool is we can actually manually input that decimal or hexadecimal number. And it takes a little bit of time, but you can do it that way. There's other ways that are faster, but we do offer you the ability to manually input the ID from an old sensor onto a new sensor for a specific application. and actually install that. The fourth way is called Auto Create. And on the slide, you can see next to Auto Create, it says Auto Create 1 to 16 sensors. Another unique offering from Autel. So we can take our tool and we can program up to 16 one sensors at a time. So if you were to lay them out on the table, you could take the tool and program all 16 for a specific vehicle application. The only difference between this method and the other methods we discussed is that all of the batch program sensors will have unique IDs and they're not based on any existing sensor information in the vehicle. So that's an important distinction. But if we're servicing fleets, police, fire, medical personnel vehicles, we can actually create a bin for each type of fleet vehicle and have them pre-programmed and on the shelf ready to go. Also, if we're servicing one vehicle and we know we're replacing all 4 sensors, we could put 4 sensors down on the table, choose Auto Create 1 to 16, and we can batch program those 4 sensors for a specific vehicle, do our relearn, and then we're on our way. So let's move on. We just covered the 4 different programming methods. What I want to do is discuss Autel's diagnostic process. So we're a diagnostic company. Our roots are in advanced diagnostics, module programming, bidirectional control, advanced scan tools, really. So over the years, we've accrued so much experience from creating our diagnostic scan tools that we were able to take the information or the bits of information that we needed for TPMS service from our larger tools and consolidate that into a very, very powerful and proficient TPMS program. So let's talk about our diagnostic process. Our experience in diagnostics gave us a unique perspective on what technicians need and what the processes need to be to simplify TPMS service. So another Autel exclusive, we're going to show you how we do it. There's a lot of tools that do it different ways, but we've tried to make the diagnostic process, what we refer to as TPMS diagnose, as simple as possible. So when we approach a vehicle with a TPMS issue, there's information we need to collect from that car in order to draw our conclusions and plan our repair process. So what is the information that we'll need? Our pressure, temperature, our battery life. So if there's a low battery on a particular sensor, the tool will indicate that that sensor has a low battery. Also very important because they have a similar duty cycle. So if one sensor has a low battery, then you'll probably see subsequent failures from the other sensors as they were installed at the same time. It'll also tell you if the location matches, the location of the sensor ID and the wheel matches the information in the car's control module. Remember earlier, we're trying to achieve continuity where the wheel locations and the IDs match the information in the controller. So it'll tell you if someone rotated those tires and didn't relearn the vehicle, and as a result of that, it's showing inaccurate information on wheel location on the dash. It'll also tell you if there's any DTCs or diagnostic trouble codes present in the system. And it'll also tell you if there's a duplicate sensor ID. Sometimes technicians in error will duplicate the ID on an existing sensor in the car, or they'll perform a copy by activation on one wheel and install the new sensor in another wheel. So when you have 2 matching sensor IDs, it's very difficult impossible in fact, for the vehicle to differentiate between those different systems, or those different sensors themselves. So you will get an equipment failure or a blinking light if you do have a duplicate sensor ID in most cases. Also, we make it very simple. We'll give you an explanation of the malfunction. So we'll actually tell you through an icon-based system, a simple, easy-to-read icon-based system, what the issue is. Any icon displayed in red requires corrective action. Anything that is displayed in green is in good condition. So even if you don't understand the meaning of the icons, we give you a written explanation at the lower left-hand corner of the screen. So we're going to take a quick walkthrough on what a diagnostic process looks like on the TS508, just so you can get an idea for how the workflow of the tool is organized. So as you can see in the illustration, this is a shot of our main menu after a vehicle selection has been made. So after we choose year, make, and model, everything on the tool happens in sequential order. So The option number 1 is the item that's always designed for you to do first. We recommend always doing a TPMS diagnose. The second step would be, if required, to program a sensor, and the third step would be the position relearn. So what we're going to do now is walk through a diagnostic process, and we're going to show you how to achieve the TPMS status screen. As with everything on the tool, instructions are displayed as soon as we choose the item that we'd like to perform, or the service item. In this case, we're going to choose TPMS diagnose, then you'll see your instructions. So it'll ask you to trigger all the sensors. So the first thing you'll do is activate your sensors, starting with the left front, right rear, left rear, and it will indicate to you if that vehicle is equipped with a TPMS sensor in the spare, as they sometimes are. So what we do is we go around the vehicle, we activate each sensor, and the tool is collecting information from each wheel location. It's making a note of the pressure, temperature, battery life, sensor ID, all the things that we discussed earlier. So the tool's retaining that information. After we're done activating the sensors, the tool will then ask you to plug into the vehicle's diagnostic port. So in doing that, we communicate with the computer that's controlling TPMS in the car, and that's going to compare the physical wheel locations and the sensor IDs with the wheel locations and sensor IDs stored in the vehicle's control module. Because remember, what we're looking to achieve is consistent information. So you'll see the tool will ask us to plug into the plug the OBD2 cable into the diagnostic port, and then after a short period of communication, just a few seconds, you'll see the TPMS status screen. So we see a collection of icons, both in red and in green, and we see a picture of the vehicle. Okay, so as you can see in the slide, it's very simple to interpret what the issues are with this system and what items we need to correct. So right off the bat, we look at things in red. We can see that the inflation pressure in the front left and the right rear needs to be adjusted. We can see we have a low battery in the left rear, so we have a low battery condition. Once we do this, excellent opportunity to go ahead and call that customer and say, you have one sensor, we're installing the second set of tires that are probably going to last you the next several years. It would be a really good idea for us to replace all 4. Right? Great benefit to the customer because they don't have to come back and have the tires broken down again to install new sensors. You could actually use the arrow keys on the tool even if you're not sure what the icons mean, and it will give you a written explanation at the bottom left-hand corner of the tool, and that'll tell you exactly what the circumstance is. As you can see at the right rear, you have the sensor activation icon, or the little wave icon, looks like Wi-Fi, and a little OBD cable icon that are displayed in red. This indicates that the sensor ID doesn't match the information stored in the vehicle. So we require a relearn to correct that. We can also see that on the dash we have a TPMS icon. If that icon is illuminated in amber color, that means there's a DTC or a trouble code in the vehicle's TPMS system. If it is gray, there are no codes present in the system. So really easy, we can retrieve those codes and take a look at a description of the malfunction and the trouble code itself related to TPMS by selecting that TPMS icon with the arrow keys and selecting it. If you choose, you can push Y for additional information or details if you need it, and it will indicate the other items to you. And as you can see, like we just mentioned at the right rear, you have mismatched sensor IDs, which needs to be corrected, along with the other relevant information like pressure, temperature, and you see that there's a low battery indication at the left rear. Okay, so that's a quick way that we can show you how easy it is to perform a TPMS diagnose and achieve the TPMS status screen, as well as interpret it on a TS508. Here's an example of how we retrieve diagnostic trouble codes on the tool. So we just select the TPMS icon on the hood of the car once we've completed our TPMS diagnose, and we'll see that it's going to give us the code and a description of that code.
So, hey, John, a couple of quick questions here. I wanted to stop you for a minute before we move on to the rest of the presentation that seemed to come in from the group. One that a lot of them are wondering about is, will the Autel tool work with all sensors rather than just the Autel MX sensor?
Sure, Mike. So any car that comes into your bay the Autel tool will be fully compatible with. So you could service any vehicle that comes through the door. When you're replacing a sensor, the only blank sensor or universal programmable that can be programmed by the Autel TPMS tools are the one sensor. In terms of aftermarket, it's compatible with direct fit sensors and also multi-application. Because of the coverage level that we have and the continuity that exists, because we're the only ones that make the tool and the sensor, there really would be no reason to go beyond our complete solution.
Excellent. And some of the guys were asking when we talked about batteries, can you replace the batteries in a sensor, whether it's the Autel or the OEs or others?
That's a good question. It's something we get fairly often. The sensors are designed to put up with a very high level of corrosion, temperature differential, so they're very well sealed, and they do need to, to be able to withstand all of the water intrusion issues and moisture and pressure that can happen inside the tire environment. So they are sealed, and as a result of that, the batteries are not serviceable.
Excellent. Well, great information, John. And I guess I'll hand it back over to you up there in New York to finish out your presentation and, of course, do the live demo that you're going to be doing for these guys as well on an actual vehicle. We'll get to some more questions with everybody here at the end.
I want to spend a few minutes talking about Autel's TPMS product line. Autel's the only company in the world that manufactures both a tool and a sensor. This is the MX-Sensor 1 sensor. This is a single SKU, dual frequency, universal programmable sensor. You can use the one sensor for virtually 99% of vehicle applications, so it's extraordinarily versatile. One of the features that we really like about the one sensor, in addition to the multitude of applications it covers, is it actually has a push button valve stem release system. So I can actually take this sensor and push the button here. I can release the rubber stem, grab a metal stem, and I can insert it until it clicks into the very sturdy retention system. So all we have to do is swap the stem and install the sensor. Very, very simple. The sensors ship with rubber stems. They're also available with metal stems. However, the stem kits themselves come in packs of 4, so you can get the metal stems or rubber stems in packs of 4. There are a lot of advantages that come with being the only company in the world that produces both a tool and a sensor. The same engineers that design the software for the sensors and the electronics also design the tools themselves, and we test and validate all of our applications in-house. Better compatibility, a higher rate of successful outcomes when performing TPMS-related repairs, and also our tech support is extremely knowledgeable on the tool and the sensor itself. So our support is really your one-stop shop for any issues with your tool or your sensor. So this is the TS508, and the TS508 is Autel's flagship TPMS tool. So this tool will address any vehicle that needs to be serviced in the bay for a TPMS-related issue. It's available in 2 different variations, the TS508 and the TS508 Wi-Fi. Functionality and coverage are exactly the same, and tool operation. The only difference between the TS508 and the TS508 Wi-Fi is technicians have the option with the Wi-Fi tool of updating the product through its shop's Wi-Fi network, whereas the standard TS508 is connected to a PC through a USB cable and a program installed on the computer to update it. So that's the difference between the 2 tools, and it's a good time to note that when you do receive your Autel tool, or even if you already have one, the first thing you should do is go ahead and check to see if it's updated. Autel software gets released so quickly. We're constantly offering new vehicle applications, revisions for older software, and new features. Also, a lot of it is not preloaded when you take delivery of the tool just because the software updates move so quickly. So be sure to update the tool as soon as you get it to utilize all of its functionality. So moving on from there, we'll talk about the TS608. TPMS tool. Now this is primarily a TPMS service tool, but it's actually 3 tools in one. So in addition to all the TPMS functionality that the 508 and 508 Wi-Fi have, the TS608 adds the capabilities of scanning and clearing codes in all computer modules in the car, not just limited to the TPMS systems. So read and clear codes from every module in the vehicle, as well as view live data streams from every one of those systems. And the third area of functionality on the TS608, which I believe probably represents the best value in the product, service functions. So service functions are software operations that help technicians perform the daily vehicle services that they need to in order to satisfy their customers' demands. So examples of service functions that we'll use every day in the shop, and there are over 20 on the TS608. A great example would be it has a engine oil light reset or maintenance service required reset feature. It also has the ability to service electronic parking brake systems. So EPB, any vehicle equipped with a newer push-button style parking brake system has a special requirement when the rear brakes are replaced to put that vehicle into service mode and create additional clearance for the new brake pads. Steering angle sensor. I know in many of your shops you're performing wheel alignments after tire installation or with any front-end service that may require it. Steering angle sensor calibration is available on this tool. So there's so many that we can talk about. For example, BMS, or battery management system. Many of the new vehicles on the road require the battery to be registered once it's replaced in a car. Electrical systems have become so sophisticated that the vehicle will actually increase the rate of charge as battery performance degrades as it's in the car longer and longer. So similar to any of our electronics or our laptops, cell phones, battery degradation happens over time, and the car adjusts by increasing how aggressive it charges the battery. So battery registration is starting to become a prerequisite in many modern cars. So there's a long list of features, and I'll put up an illustration with some of them, and you can take a look at that. But great form factor. The tool does a tremendous amount at a relatively low cost to acquire it. Form factor is very different between the two tools. This is a touchscreen Android-based tablet, and in addition to that, it does have Bluetooth wireless connectivity to the vehicle. So very simple to use, very versatile, excellent for a tire shop or a shop that's performing general service and maintenance. Just a couple of other items. In addition to our metal and rubber valve stem kits that are available in packs of 4, sold individually are actually custom colored valves. So we offer chrome, we offer Titan gray, which is a dark gray, and we offer a matte black metal valve stem. So we have some customizability options should your customer come in with a set of chrome wheels and wants that little extra something from that installation. Very simple and quick to replace that valve stem. So if you have any other questions on any Autel TPMS related or diagnostic products, visit us at our website at autel.com. Let's get on to our vehicle service live in the bay. Now let's perform a live TPMS demonstration at our bay at Autel. This is the TS508 tool. I want to advise everyone that if you're purchasing a new one or you already have one, to make sure that you update the tool prior to using it for regular service. One of the things that we're really proud to offer is that TS508 and TS508 Wi-Fi tools offer free updates for the life of the product. So let's get started. As we discussed earlier, the first thing we want to do when we approach a vehicle with a TPMS related issue is perform the TPMS diagnose. So here's how we'll start. We'll select advanced mode on the tool and select our year, make, and model. In this case, we have a 2019 Ford Fusion. So we'll take a quick look in our door jamb, which we already did, and we got our build date to make sure that we're choosing the correct application. Okay, so we're going to choose our Fusion, and it indicates this is a 315 megahertz car. So we're going to select the application, And like we talked about, everything on the tool is done in sequential order. So diagnose is listed first, and that's what we're going to do first. So let's diagnose the car. The first step is, of course, going to be activating each one of the sensors so the tool can collect information on the wheel locations, the sensor IDs, pressure, temperature, battery life, and so on. So we'll select TPMS diagnose, and shows us a photo of icon of the car, and we're going to activate each sensor. Okay, so we can see that the sensor in the left front failed to activate. So we're going to move on to the next one. So that activation failure is going to indicate that we have a faulty sensor, but we'll move on and check the others. Okay, so the other three sensors activated successfully. Now the second part of the diagnose process involves us plugging into the vehicle's diagnostic port with the ignition on. The tool will then communicate with the car and compare the wheel locations and the IDs we collected from the vehicle through activation with the information stored in the control module. In addition to that, it's going to look for any TPMS-related diagnostic trouble codes that are present in the system. So let's go ahead and plug in, put our ignition on, and we're going to communicate. The tool's reading the sensor IDs, checking diagnostic trouble codes. Okay, and it's running through a quick system test. Read ID successful and read DTCs successful. So we'll press OK. And I'm going to unplug from the vehicle. And we're going to talk about the status screen. So if you remember what we reviewed earlier, the tool then displays the TPMS status screen. So as you could see, the front right, right rear and left rear activated correctly. If we look at the front left, we could see that the activation icon, what looks like that little wave icon, is displayed in gray, and that indicates that we have a faulty sensor that failed to activate. We also have TPMS-related DTCs because the TPMS icon on the hood of the vehicle is illuminated in amber. We could also use the arrow keys, and as we select each wheel location, you'll see a written explanation at the lower left-hand corner for each malfunction. Okay, so you can see as we select each wheel, it's going to tell you the nature of the issue. Okay, so we've come to the conclusion after our diagnosis that we need to replace the sensor in the front left wheel. Okay, so what we're going to do is we have the car set up, we're going to lift it, remove the wheel, and get over to our tire machine. So now we've determined that we need a replacement sensor for our Ford Fusion. And the next step is creating or programming a sensor for this vehicle application. So we're going to take an Autel 1 sensor. Now remember, these are universal programmable, so they're blank, so we have to create a sensor or give it the identity that is compatible with the Ford Fusion. So what we're going to do is, on our vehicle main menu, we see TPMS diagnose was the first step. We're going to move on to the second step, which is program sensor, and we'll select that. And in this particular case, we're going to use the auto create sensor programming method. So all we do is place our sensor at the top of the tool in the cradle, and you don't have to do this, but it's great for one-handed operation. And let's press Y. The tool will search for sensors, and we see one sensor detected. Do you want to continue? So the tool is asking us if we want to program the sensor for the Ford Fusion. Let's press Y. Okay, so now the tool is teaching this one sensor how to perform exactly like a factory sensor for this car. Okay, so now we've created a sensor that is compatible with the Ford Fusion, and we're going to go ahead and install it and then perform our relearn procedure. So now we've installed our replacement valve, and one of the things that's unique about the Autel MX-Sensor 1 sensor is we have a push-button stem mounting system. So there's no longer a requirement to tighten a torque screw to secure the sensor body to the valve stem. So all we have to do is simply press the sensor body onto the base of the stem, and it'll snap right into place, just like that. Very simple. So now we've completed our sensor installation in our 2019 Ford Fusion. Now comes the point where we have to perform a relearn on this vehicle. So anyone who's familiar with Ford relearn procedures understands that there's a higher degree of complexity to those procedures. So Fords with ignition keys require you to cycle the key off to on 3 times, pump the brake, off to on 3 more times, and then pump the brake again. This then puts the car into a train mode, and you'll then be required to activate each sensor in a sequential order. The horn will honk, and then the car will recognize that the IDs have been registered, as well as the wheel locations. So that procedure, sometimes to get the cadence and the timing correct, can be very difficult depending on the vehicle, and it takes quite a few tries if you're even lucky enough to get the car into learn mode. So Autel engineers identified this problem, and we created a solution for it. In this case, it's even more difficult because this Ford is equipped with a push-button ignition system. So it requires pressing the button on and off approximately 12 times and pushing the brake pedal sequentially in order to get that car into learn mode. So we thought this was way too difficult and a little bit too complicated to carry out in the shop on a regular basis. So we thought about how we could streamline the process. So what Autel engineers have done is we've engineered a way to do the relearn procedures on these Ford vehicles with push-button ignitions using a simple OBD relearn procedure similar to many Asian vehicles. So let's take a look at our menu system on the tool. And we can see that we've completed our TPMS diagnose already, programmed and installed our replacement sensor. And now the third step is the position relearn. So we'll select the third step, press Y, and as you can see, we offer you different options. If you want to use the factory relearn method with pressing the ignition button or cycling the key, you can choose to do so with the stationary relearn, but we make it much easier for you. So select OBD relearn. Let's press Y, and here are your OBD relearn instructions. As with all of the processes on the TS508 and 608 tool, everything is explained to the technician as they go through the repair process. So we've read our directions. Let's press OK. We'll see the picture of the car, and then we're going to move on and activate each one of our sensors. So let's activate our sensors, starting with the left front. Okay, activated right away because we installed our newly programmed one sensor. Now that we've completed our sensor activation, the tool is asking us to plug into the vehicle's diagnostic port to upload the IDs. So now we're communicating with the vehicle and uploading the new locations and the IDs of the sensors. And we'll just let it go through that process. Okay, so our TPMS relearn was successful. So Autel has automated the entire relearn process that would have ordinarily taken many, many steps to complete. So now we can see that the tool has performed an additional TPMS diagnose and indicates that all systems in the vehicle are okay. Thank you for joining us for today's training presentation. We hope you benefited from all the information we gave you, both on technical items related to TPMS as well as Autel tools and sensor products. We're now going to move on to a Q&A session where our technicians will try our best to answer all of your questions. If we don't get to any of them, please visit us at autel.com, give our tech support a call, or drop us an email.
Well, hey, John, thanks. That was some great information. A couple of questions that I see that should be common for some of the guys we might want to touch on. One is some of the guys were asking about the ability to reprogram a sensor after you've reprogrammed a sensor once you already did it, or if you can program a sensor after it's already been installed in the tire.
Okay, great question. So we do offer the ability to program the sensor again once it's installed in the tire. So this is something that you'll run into now and then if you accidentally choose the wrong vehicle application or the wrong model year. Our tool is set up so that once the sensors are under pressure, the tool will not allow you to reprogram through the sidewall of the tire. However, if you go to the options menu, we do allow you to reprogram that sensor through the tire under pressure. The reason that it's not available without choosing the setting is we want to be very careful when we're programming through the sidewall of the tire that we don't accidentally program another sensor either at the spare or the opposite wheel location. So in the TS508, in the options menu, there's a feature called TPS program limit, and you can switch that off, and then that will allow you to reprogram through the sidewall of the tire. And that's only going to be a redundancy in case you run into trouble. Ordinarily, you'd always want to program and prepare your sensors before you install them in the tires, but we do offer you that capability.
Great, John. Another one that several have asked about is vehicles that when you're going through, they show both a 315 or the 433 frequency. And how do you handle or determine which way to go when you see that on the cars?
The first thing you want to do is you want to be aware of the build date on that vehicle, because sometimes you'll have a model year with two separate build date periods of time, and one will be 433 and one will be 315. Pay attention to that data manufacturer. Now, there are instances where you will have during the same production period cars that are offered in a 433 and a 315 megahertz function. So a really easy way to figure that out if you're not sure is just select the first application and try activating a sensor, and then try the other frequency. The sensor will only activate if the correct frequency is installed. Another way that we can do this is in the 508 menu system, there's a feature called RKE and RF. So it stands for Remote Keyless Entry and Radio Frequency. And that feature is designed to test the transmission signal strength and determine the frequency of a keyless entry remote. So it's just a little added feature. It turns out the wireless control on most vehicles we work on, the key fob, the keyless entry remote, and the TPMS system will work on the same frequency. So you select RKE and RF, grab your keyless entry remote, press one of the buttons, and the tool will display the frequency of the signal coming out of that, which will match the frequency the TPMS system is running on.
Last question that seems to be a good general one from everybody is about OBD2 Relearn. Do all cars have that OBD2 Relearn function?
OBD Relearn is the factory procedure for most Asian vehicles. So the way that we implemented the OBD Relearn in additional applications was to use it on domestic vehicles, meaning US North American vehicles, and I believe some of those are available in other regions as well. But any cars that require a more complicated multi-step procedure, through our engineering know-how, we're able to streamline that process. So OBD Relearn is only available on domestic vehicles. It's going to be Ford, GM, and Chrysler. An interesting thing about the Chrysler vehicles is we can perform that OBD Relearn and actually avoid the test drive that would be required to perform the auto learn or for the car to localize those wheels, because it does have an automatic relearn function. So in inclement weather or in situations where it's prohibitive to drive the car, you can use that on auto learn features. Another example of that is if we have a General Motors car, if we recall, the way to initiate the factory relearn procedure on many GM vehicles is to have the key in the ignition and hold the lock and unlock button on the keyless entry remote. In some instances, customers won't have the remote, or they will have lost it or not provided that to the repairer. So without that remote, you wouldn't be able to get the car into a learn mode. The 508 and 608 are able to bypass the need for that and communicate directly to the control module and upload those IDs. So it's very handy.
Thank you for some great information, John, and a great presentation. And I want to thank everyone for attending today's webinar. On behalf of Autel, our panel, we want to thank you all for joining us today, and have a great rest of your day.